In this video on financial calculations, I'll go a little bit quickly, but of course you can stop and rewind as you need. Pull out your calculator and try to calculate with me as well to make sure you're punching things in the right sequence to get the same numbers as I do. In this unit, we use three formulas, either simple interest, compound interest, or annuities. Simple interest you can tell because the question will tell you simple interest. Compound will also tell you about compounding. And in an annuity, you're using multiple regular payments instead of one lump sum. We also talk about loans and mortgages, but those are just a combination of these two formulas. The first thing I always do is write out my 5 variables. Principal, interest, always given annually, compounding periods, total interest periods, and accumulated amount. Here I can see that the amount I'm investing, the principal, is $1,200. The interest rate is 0.05 or 5%. If I'm using simple interest, I can choose how often per year I want to compound because it won't make a difference. So if I've got half years to work with, I'll choose to compound twice per year, which means I'll have 6 plus 1, 7 total half years or 7 interest periods in total. And then I'll solve for my accumulated amount using the formula P times 1 plus I times N over M. Plugging this into my calculator, I get an accumulated amount of $1,410. In terms of interest earned, I started with $1,200, I ended with $1,410, so if I subtract those two values, $1,410 minus $1,200 tells me that I earned total interest of $210. This problem has the same variables, except now instead of saying simple interest, it tells me that the account compounds at a certain rate, in this case semi-annually. So I know then I should use the compound interest formula because I see the word compounded. Plugging into my compound interest formula, $1,200 invested at 5% semi-annually. This time N is a power instead of a multiplier. And plugging this into my calculator, I end up with $1,426.42. So when we were compounding or earning interest on our interest, we made about $16.50 more in those 3.5 years. If the account compounds monthly instead of semi-annually, the only thing that changes is our M and our N. Monthly means 12 times per year. So in 3.5 years, that's 12 times 3 is 36, plus another 6 months, that's 42 months or interest periods in total. So that's 12, that's 42, and based on this new calculation, that's $1,428.97. A little bit more when we compound more frequently. And this can really add up if we've got bigger amounts of money, bigger interest rates, or longer time periods. This time, I'm investing $1,200 in an account offering interest compounded weekly, and I'm being asked what rate I should look for if I know that I need to have $2,000 in the account after 5 years. So same P. My M is going to be 52 since I'm compounding weekly and there are 52 weeks in the year. After 5 years, that's 52 times 5 makes 260 total weeks or total interest periods. This time, it's I that I don't know and my accumulated amount that I do know. So when I plug into my formula now, I know the accumulated amount. There's my P times 1 plus I don't know. M is 52 to the power of 260. We'll have to follow a series of steps to solve for I. In the first step, I divide both sides by 1,200. I always do this first, leaving me with 1.67 is equal to 1 plus I over 52 to the power of 260. The next thing I need to do is get rid of this power of 260. The way that I do that is to either take the 260th square root of both sides, there should be a button on your calculator for that, or I do the reciprocal power to both sides, the power of 1 over 260, which is the 260th root. On the right side, that just means those powers will cancel, and I'll just be left with what was in the brackets. On the left side, I punch this into my calculator, either using the power button or the square root of 260, and I get 1.002. The next step is to subtract 1 from both sides, or in other words, move that 1 over. So 1.002 minus 1 leaves me with just 0.002 equals I over 52. Then let's multiply both sides by 52 so that those 52's cancel out. And in my calculator, I see that 52 times 0.002 equals 0.1022, or in other words, the interest rate I should look for is 10.22%. So this is another compound interest example, but solving for interest instead of accumulated amount. How about an annuity? In this example, we're again putting away money to save for an accumulated amount, but this time I'll use an annuity formula. The reason why I know it's an annuity question is because I'm putting away money multiple times and not just one lump sum. So this time, I want to put away semi-monthly payments to save an accumulated amount of $10,000. My account offers interest at 8%, compounded semi-monthly means twice a month, so in 1 year, that'll be 24 times. And if I leave it for 2 years, that's going to be 24 times 2, 48 total interest periods. And I want to know, what should my monthly payments be? So plugging this into the annuity formula will look like this. 10,000 is equal to P, which we don't know, times 1 plus I over M to the power of N, then minus 1, divided by I over M. When you calculate this, I suggest going from the inside and working your way out, and then taking 10,000 and dividing by that amount to solve for P. So in this case, you end up with a monthly payment of $192.45. So notice that if I paid 48 monthly payments of $192.45, I won't get exactly $10,000. I'll have less than $10,000. But because I was putting this money away into an account that offers interest, I can put less than $10,000 into the account, but with interest, it'll end up being $10,000 in 2 years. What if we want to do a mortgage? Like I said in the intro, this is just like an annuity, except we combine the compound and annuity formulas into one, because there needs to be 2 points of view here, a borrower point of view and a lender point of view, and it doesn't matter which one goes on which side. The lender says, I'm giving you $1 million that I could have invested in this account at 2.5% compounded monthly, so 12 times per year, for a total of 20 years. So 12 times 20 makes 240 interest periods. So from the lender's point of view, this is actually how much that million is worth. It's worth 20 years of investing $1 million. From the borrower's point of view, we need to make monthly payments into an account offering 2.5% interest compounded monthly for 240 periods. That's monthly for 20 years. So we're using the annuities formula because we're making regular monthly payments, and what we put in as the borrower needs to match what the lender could have done with that million over this amount of time. So here again, you're going to do two calculations. First, you'll calculate out this amount, which ends up being $1,647,863.96. So this lender could have made almost $650,000 of interest if they'd invested it instead of giving it to you, so you need to pay that down. Then you're going to calculate this amount and divide that 1.6 million by what you get here to figure out your monthly payment, which in this case will be $5,299.10. So if I decide to buy this mansion, I'm going to need to be able to put down a hefty monthly payment in order to pay down that mortgage. The second part says, what would the payments be if you make a $1,000 down payment? So if I'm making a $1,000 down payment, that means that instead of $1,000, let's just use the same formula here. Instead of $1,000, now the lender only needs to give me, instead of $1 million, $900,000 because I've paid down $1,000 up front. Again, you do the calculations. This time on the right-hand side, you're going to get $1,483,077.58. So by paying down $100,000, I'm saving myself $100,000+ in interest. So it's always worthwhile to make a down payment if you can. Again, solving and dividing our 1.4 mil by what we got on that left-hand side. This time the payments should be lower. They'll be $4,769.20. Now, if I want to figure out the total that I've paid 240 payments of $4,769.20. So if I multiply that by 240, I can see that for that $900,000 mortgage, I actually paid $1.15 million. So you're paying quite a bit in interest when you take out a big loan. What about the last part of the question? What would the remaining principal be after 5 years? Remaining principal is how much of the loan is left, just the loan, not the interest, after you've made these payments. So in order to do that calculation, this time we know what the payment amount is. So in our annuity side, in our borrower side, we're going to use that value as our P. We've still got the same interest rate, compounded monthly, but now for our N, we're going to use the remaining amount of interest periods or payments. We started with 240. If we've been paying for 5 years, that's 60 payments we've already made. So 240 minus 60 means we'd have 180 remaining payments. So that's our new N. When we're talking about remaining, then we should always use the N for how much is remaining. So the rest of our annuity formula looks like this. There's our borrower point of view. And from the lender point of view, how much would be remaining that they could have invested at 0.25 compounded monthly for those remaining 180 interest periods. Now we calculate this part first, then divide by this part to give us a remaining principal of $715,248.52. I hope that helped you with your financial calculations. Enjoy the course.